Hello everyone, welcome to Coders Camp. We are at 22nd day of December LeetCode challenge and the problem we are going to cover in this video is reorder list. So we are given a head of a linked list as our input and we have to reorder the list and again return the head of the linked list. So in which order we have to reorder is if the list starts from 0 to n, then we have to arrange it in such a way that the nodes come in 0, n, and 1, n minus 1, 2, n minus 2, and so on. So for this example, 1, 2, 3, 4, first one had come, and after that, the last node had come to the second position, and then the second node, and then last but one node has come to the fourth position, and etc. So how are we going to approach this? Let's see. So here's the given example in the problem statement. And as I said, the first node is not going to change its position. So after this, we have to connect first nodes next with the last nodes next. And the last nodes next is going to be connecting to the second nodes previous and so on. This is going to connect with this and this is going to connect with this. And this keeps going on till we finish all the nodes present in the linked list. So how do we actually approach this? So if you observe this problem, we have already solved this in two other problems separately. That is reverse linked list 1 and 2. We have already posted those videos. So this problem is nothing but three sub problems that can be combined together to get a solution. So let's see one by one. So here is the given linked list. As I said, we are going to go through three different sub problems or three problems to solve this together. So the first step is to split the list into two lists. So now we got two lists. So the next step is merging the list. But before merging the list, how do we actually want to merge the list? So if you see, we have to merge the first node of the list 1 with the last node of the list 2 and so on. So in this case, we need to reverse the second part of the list to make it easier. So once we split the list into two, we have to reverse the second part of our linked list. The first half or the first list stay the same and the second half will be reversed. After reversing, the step 3 is to merge it. So once we reverse, it is easy for us to merge the first node of both the lists and the second node of both the lists and so on. So if you observe or if you have watched our videos already, we have solved reversing a linked list already, also merging two lists already. So this problem is a combination of these both. So let's see how we're going to do this. So now, as I said, the first step is to split the list into equal halves. So first of all, how do we find the mid of a linked list? Is always using the two pointer technique. One is fast pointer and other one is slow pointer. So the fast pointer move two step at a time and the slow pointer move one step at a time. So this is a usual algorithm two pointer technique to find the mid of a linked list every time we have used. So as the fast pointer moves two step ahead, the slow pointer move one step ahead. So at the first position, the slow pointer will be here and the fast pointer will be here. And at the second attempt, the slow pointer will be at 3 and the fast pointer will move to the end of a linked list. And the next node will be null. So it means we have reached the last node by using the fast pointer, and wherever is the slow pointer is staying, that is the mid of a linked list. So that is the point you have to exactly split the linked list. So what we do now is we set slow.next is equal to null. So what it does is it set the list to 1, 2, 3 and slow dot next is equal to null. So this forms a linked list, and from 4 we would form another linked list. So 4, 5 and 6 and then null forms another linked list. So yes, the first step is done. The second step is to reverse the linked list. So again, reverse the linked list is a separate problem where we have seen different solutions to reverse a linked list already. So you must be familiar by this by now. So just telling you the overall logic of reverse here. So what we are going to do is before the first node, we are going to set the first node or head of the linked list dot next is equal to null because this is going to be the end of a linked list. So end always head towards the null node. So we first set the null this dot next to null. So we keep a pointer temp to keep track of the next nodes because we would be losing the connection between them while we connect it to null. So the next step is to connecting the temp dot next to this node, the current node. So what we do, we make a connection between temp and current. So to not lose it, we shift the temp to here, and then we make a connection between this node to this node. And again, similarly, we terminate the connection between these two and make a connection between this to this. And again, if we encounter null, which means we have to make the last node as the head of the list. So now this list will be reversed to 6, 5, and 4. So this is just the overall logic, that we just reverse the connection from the first node to null and then the every adjacent node to the previous node. And that's it. To do that, we'd be using 3 pointers. So we have seen this already in detail. So I'll attach the video link if in case you want to watch it in detail. So as I said, we are done with 2 steps, splitting and reversing the second half of the linked list. Now we got 2 linked lists which has to be merged. So again, this is another problem, that is merging 2 linked lists. That also we have done already. So what we have to do is we are going to have a pointer list number 1 starting at the head of the list 1, and list 2 is going to start at the head of the list 2. And also we are going to have temp1 and temp2, or n1 and n2, which means next one and next two, however we want it to be. So let's say next one and next two. So now these pointers is going to help us to link each node from the lists. So the first node is going to have 1 from L1. So now L1 dot next is going to connect with L2, because that is the first node in our linked list. So we are going to connect 6 here. So once it is done, we are going to remove the connection between L1 and N1, because we have connected L1 and L2. So just to keep track of the node 2, we are going to have the N1 pointer, because we should not lose track of the rest of the list. So now once this is done, we are going to connect L2 dot next to N1, because that has to be the second node. So once we connect 2 here, this connection will be terminated between L2 and N2. So that is why we kept N2 here, to keep track of the rest of the lists. So once we done this, automatically we know after every iteration the pointers move one step ahead. So now this becomes L1's L1 pointer and N1 here. The same way now L2 becomes this and N2 becomes this. And we have to again make the same set of connections, that is from L2 to N1, from L1 to L2 first, and then L2 to N1, and then N1 to N2. Or otherwise L2 will be moved here. So we have to keep connecting them till we reach end of both the linked lists. So yes, once this is done, it will be merged to however order we want it to. So yes, that's it. So yes, as I said, this problem is combination of the other 3 sub problems, where we have solved them in detail with diagrammatic and graphical representation in our channel already. So I'll link those links in the description. So before getting into code, this is going to work in big O of n time and big O of 1 space complexity. So let's go to the code now. So here is the code for this problem. So here is our main method. So before getting into the main method, let me show other 2 sub methods we have. The one is to reverse the linked list. This is a separate code or separate problem. And one is to merge 2 linked list. So you must be aware of this code already. So as I said, in reverse, we are having 3 pointers: previous, current, and next. And every time we are making a connection between current and previous. That is, current node will be the current node you are iterating, and every time we are going to make a connection from current dot next to previous. That's the simple technique we are going to use to reverse the complete linked list. The other 2 pointers are helping us to accomplish that, because we have to keep track of the previous and the next nodes to build the connection. So yes, until current is not is equal to null, we're going to keep naming current to current dot next to current dot next, and then current dot next will be assigned to previous, and then we will move the pointers previous to current and current to next. And once the iteration completes, the list will be reversed. And again, coming back to the merge method, so this will help us to merge 2 linked lists, which is again a simple code. So we have pointers n1, n2, l1, and l2. So L1 is the head of linked list 1, and here we pass head of 2 linked list L1 and L2, and here N1 is the linked list 1's next node and N2 is linked list 2's next node. And what we do is we connect L1 dot next to N2 because always the first node from L1 will be the first node, and if we reach null we are going to break the loop. If not, we are going to connect L2 dot next is equal to N1 because from the list to L2 we'll connect N1, and once it is done we just move the pointers ahead to keep swapping the links. So yes, this is it. Let's go back to the main method. So we are checking the base conditions that if the linked list is null, so return null. And as I said, we have to first find the mid of the linked list and split it into two. So to do that, we are going to use a slow, a fast, and previous pointer. And also we initialize L1 here as the head of the first linked list or head of the linked list given. So as I said, we are going to iterate until a fast pointer meets the end of the linked list, and we are going to keep swapping or keep moving slow to by one node and fast by two nodes. Also, we are going to keep moving previous as the slower node because we have to split it, right? So now our slow will be in the mid and fast will be in the end after this completion of the while loop. So once it is done, priv node pointer will also point at the mid of the linked list. So priv dot next will be equal to null. That will actually split the list into two. So once this split into two, we are going to simply reverse only the second half of the linked list. So we are going to call reverse of slow. So what it actually does, from the next node to slow, it will reverse completely. So once this is done, we are going to merge the list 1 and list 2 because we have assigned the reversed list to L2 and we are going to call the merge. So once it is done, obviously this is going to return void because the head of the linked list is going to be the output it is going to take. So already we have done all the connections we want to make, and head of the linked list will be the actual reordered lists head. So yes, let's give it a try and see whether it works. Yes, so let's submit. Yes, the solution has been accepted and it runs in 1 millisecond. So thanks for watching the video. Hope you like this video. If you like this video, hit like, subscribe, and let me know in comments. Thank you.